Good morning, one and all. I am Dr.S.Murugan, Professor of EC Department, P.S.R Engineering College, Sivakasi. Today we are going to see about elements of fiber optic communication. So first of all, we discuss about communication. What is the purpose of communication? What are the requirements for communication? And we will see the difference between ordinary electrical communication and fiber optic communication, and finally we see about the elements of fiber optic communication. So first of all, in olden days, communication is meant for transmitting data from one place to another place. So the olden days communication is by means of fire lamp or by means of acoustic sounds. After that, Morse code was introduced for sending the electrical signal for transmitting the information from one point to another point. So in electrical communication, we have used twisted pair wires, then coaxial cable, waveguides for transmitting the information from one point to another point. So the important requirement for communication system is to achieve high data rate and transmitting the data over the long distance. The high data rate is achieved by using high bandwidth channels, and we have to use very low attenuation channels for increasing the transmission distance. So in olden days, we have used twisted pair wires for low frequency signals, since only audio signals we have transmitted from one place to another place. And day by day, this data amount is increasing, and we need huge amount of data to be transmitted from one end to another end. How we can send huge amount of data? The only thing is we have to use high frequency carrier signal in order to carry out more information over the channel. But when you are increasing the frequency of the carrier, automatically the bandwidth of the channel will increase, and therefore the information capacity will increase. So that is the idea of electrical communication, to achieve high data rate and high capacity channel. But what is the disadvantage here? So in the case of electrical communication, we have used coaxial cable, which is made up of conductors. So at higher frequencies, skin effect comes into picture. This skin effect is nothing but after certain distance of transmission, the signal will get attenuated to 36% of its original value. Suppose if you are sending a 1 volt signal at the transmitting end, you will, after reaching this skin distance, only 0.36 volt of your original signal will be obtained. Below this value, 0.36 volt, the receiver could not receive the signal properly. So the ultimate purpose of communication is you have to retrieve the signal as it is from the what you have transmitted from the transmitting end. So skin effect plays a major role So we have to go for some other medium where the attenuation is very minimum. So such a channel is optical fiber. So earlier optical fiber is used in medical field, especially in endoscopy, for diagnosing the tumors in the organs. So while diagnosing, they will insert, the doctors will insert the fiber into our body, and they will send the laser light through optical fiber, and they will diagnose the organ whether any tumor is present or not. So this is the earlier use of optical fiber in medical field. In 1960s, 1950s, so they thought about communication of signal by using optical fiber. But when they did the research for transmission of signal, what they have obtained is there is a huge attenuation, nearly 1000 dB per kilometer in the earlier optical fibers, silica fibers. So optical fiber is 100% pure silica, that is nothing but optical fiber. So they thought about the reduction of attenuation, how to reduce the attenuation so that the communication is possible by optical fiber. So they analyzed the attenuation characteristics of the fiber. So while plotting the graph between wavelength and attenuation, in certain wavelengths, so this is about the introduction. So you see the graph here. In certain wavelengths, the attenuation is very minimum, and they called these wavelengths as optical windows. So there are three such wavelengths, namely 850 nanometer, 1310 nanometer and 1550 nanometer. These are the three optical windows which can be used for the optical fiber communication. So after realizing this characteristics of attenuation versus wavelength, the scientists decided to design the sources at these wavelengths so that we can send the information in these particular wavelengths with minimum attenuation. Therefore, for long distance we can send this information signal to the receiver. So you know that these wavelengths 800 nanometer to 1600 nanometer, 800 nanometer to 1600 nanometer, which is called as the wavelength region for fiber optic communication. While you are converting this wavelength into frequency, it is in the range of 10 power 14 to 10 power 16 hertz. So you see the carrier frequency, which is in the order of 10 power 14. So we know that the carrier frequency is directly proportional to the bandwidth of the signal, bandwidth of the channel. Therefore, bandwidth is in the order of 10 power 14 hertz. So such a huge bandwidth is obtained in these particular wavelengths, and particularly when we see the first window, that is 850 nanometer, which was developed during 1984, has the attenuation level of 2 dB per kilometer. Next window, that is second window, 1310 nanometer, the attenuation level is around 0.5 dB per kilometer, and in the 1550 nanometer the attenuation level is around 0.05 dB per kilometer. So how we can design the sources with these wavelengths? So earlier sources, LED and laser sources are used in fiber optic communication. They are made up of silica material only. Okay, but after realizing this graph, compound semiconductors are used for fabrication of these sources. These compound semiconductors are nothing but the heterojunction structures. That is, it is an alloy of two different materials having different energy band levels. Suppose you take gallium and arsenide, both have different energy band gap. They are combined together and we can make gallium arsenide substrate. Similarly, gallium aluminum arsenide, gallium aluminum arsenide, indium gallium arsenide phosphide. These are the some of the compound semiconductors for realization of these optical sources. So the three main elements of fiber optic communication are fiber optic sources, fiber and photodetector. In this graph you are seeing here the fiber optic photodetector characteristics. That is, for the particular wavelengths, the responsivity, that is the performance measure of photodetector, is also one of the important thing. So the responsivity should be very high. This responsivity is nothing but the speed of the photodetector at or we can it is directly proportional to the response time. We can say the response time should be in the order of nanosecond for a good photodetector. So while we are designing the photodetectors with silicon and germanium, it is very that is the responsivity is around 0.5 only. When we design the photodetectors with indium gallium arsenide, the responsivity increases to around 1. That is 100%. That is, responsivity is very high. So from these graphs, what we understood is, if we use compound semiconductors for the fabrication of LED and laser and photodetectors, then the performance is increased. Therefore, we can send the huge amount of data from one end to another end over the long distance. So whenever we are coming across fiber optic communication, so you should know this fiber optic communication is especially for long distance communication because of the very low attenuation level. So this is about the evolution of fiber optic communication. So single mode fibers, multi-mode fibers are there. So after the invention of high quality lasers, single mode fibers are used for transmission of signals over the long distance. So compared to multi-mode fiber, these single mode fibers, which are using laser as its sources and is used for long distance communication. Multi-mode fibers use LED sources. The bandwidth of this multi-mode fiber is somewhat lesser than the single mode fiber. The data rate is very high for single mode fiber, nearly 10 Gbps data rate we can achieve when we are using single mode fiber compared to multi-mode fiber, especially for long distance communication, 1550 nanometer system, that is third optical window system is used for transmission of signals from one end to another end. Another important component is optical amplifier. So whenever in electrical communication, when the signal is attenuated, we are introducing the repeaters in order to boost up the signal. So a repeater consists of an amplifier, so again a regenerator, and it will send the signal. So here we are using optical communication, that is optical signal, light signal we are transmitting. So ordinary amplifiers we can't use, we have to use optical amplifiers. That means ordinary amplifiers we need electrical signal. So again, if we are using ordinary amplifiers, this light signal is again converted into electrical signal, then only we can obtain the amplification of electrical signal. Again we have to go for E to O conversion. So this conversion is avoided when you are using optical amplifiers. So erbium doped fiber amplifiers are used now. So these amplifiers immediately they will amplify the signal without any E to O or O to E conversion. They will amplify the optical signal as it is. Therefore there is no E to O and or O to E conversion existing in the fiber optic communication. So these are the major elements of fiber optic link. So when you see this block diagram, the black color line shows the electrical signal, which is our input signal. It is given to the transmitter. The transmitter consists of drive circuit and a light source. So the electrical signal is activating the LED or laser source. So where you have electrical to optical conversion is taking place. Electrical to optical conversion. So after the optical signal is coupled into the fiber, it is transmitted over the long distance, and while you are carrying out long distance communication, you need a regenerator where you have an optical receiver and some amplifier, again transmitter is required. Again the fiber is used to, that is the power, optical power is coupled into the fiber. This dashed line represents optical power is now launched into the fiber, and on the receiver side we have three elements: photo detector, amplifier and signal restorer. So the photo detector we have used is pin diode and avalanche photodiode. So the main function of photodetector is to convert the optical signal into electrical signal. And finally the signal received at the photodetector is a weak signal. So the performance of the photodetector should be very high. That is the response time and the quantum efficiency of photodetectors should be very high. So that signal can be detected by the photodetector, and it is given to the electrical amplifier. Now electrical signal is obtained at the output of photodetector. So we can use electrical amplifier now, and the signal is restored. The signal is restored in the by using the signal restorer, and the final electrical signal is obtained at the receiver. So the complexity of the receiver design is slightly complex than the transmitter design. So So we have to take care about the design of the receiver while designing an fiber optic communication system. So these are the elements of fiber optic communication system we have discussed today, and in the next video we will see about the individual blocks in detail. Thank you.